So there are two last items that I want to go over to conclude and wrap up chapter number 1 for our class, and they are density and temperature conversions. Now this is a great visual of density and how it operates. What we have here is a cylindrical piece of glassware that has a number of different substances that are all pigmented and they separate based on density. At the very top, we have a ping pong ball. Ping pong balls are very light. They float on most any surface. That's because they are less dense than, well, the substance in which they're incubating. So we've got a ping pong ball, lamp oil, rubbing alcohol, vegetable oil. Oh, a soda cap is in there. It looks like right there. We've got beads, not bees. If you've ever watched the TV show Arrested Development, well then I'll just say beads. If you've never watched that show, anyway, move on with your life. Water, a cherry tomato right there. We got dish soap, milk, dye, not the command or the German word the. Instead, a singular dice. You know, dice is plural. Singular dye, maple syrup, popcorn kernels, corn syrup, honey, and a bolt at the bottom. Okay, so all these things separate based on density. The most dense go to the bottom, the least dense go to the top. Easy peasy. All right, now density can be used as a conversion factor. And one of the things that you'll commonly see is density, and you'll look at the units of density. So for instance, what we have here, mercury has a density of 13.53 grams per milliliter. Okay, so that means that, and the way I always like to think about density is I like to think about if you have 1 milliliter of it, well, what is the mass of that substance? If you have 1 milliliter of density, it has a mass of 13.53 grams. Now, what does that mean if you have 2 milliliters of it? Well, you'd have 2 times the volume, so you'd have 2 times the mass. Bob Katz's lab procedure calls for 25 grams of mercury. I'm going to write an HG here in parentheses. The line for the balances is long, but Bob has a graduated cylinder in his kit. What volume of mercury should he measure out to get 25 grams of mercury? Okay, so this, you can do dimensional analysis in order to figure out this question. So he needs 25 grams, or they need 25 grams of this substance. So what we're going to say is we want to know the volume. So I'll say 25 grams, and I'm going to use density as my conversion factor. So I'm going to say 13.53 grams and 1 milliliter, because I know that if I have 1 milliliter, it has a mass of 13.53 grams. And what I want to know is what volume of this mercury do I need? So what I'm going to do is set this up so I'll cancel out my grams and be left with a volume. So I'll say 25 divided by 13.53. That gives me an answer of 1.84777, or 774,575. And you round this down to 2 sig figs right there, and that would be 1.8 milliliters. So essentially, Bob can use their graduated cylinder to get 1.8 milliliters of mercury, and boom, they have the 25 grams that is needed. Okay, now play around with that sort of formula, and you'll be very successful with density calculations. The same can be done if you're, well, trying to figure out what mass you have if you are specifying a volume. Okay, the next sort of calculation that I wanted to show you was temperature scales. So this shows our 3 temperature scales. Fahrenheit, our imperial system that we use here, Celsius, the metric system, and Kelvin, the chemistry or science measurement system. Our boiling point, this is all to relate the normalized boiling point of water. If you heat water up to 212 degrees Fahrenheit, it's going to boil. It's going to evaporate. It's going to convert from a liquid to a gas. If you chill it down to 32 degrees Fahrenheit, well then it's going to freeze. It's going to form a solid. If you heat water to 100 degrees Celsius, that is the exact same as 212. If you cool it down to 32 degrees Fahrenheit, that's the exact same as 0 degrees Celsius, which this 100 degrees Celsius is the same as 373.15 Kelvin. Notice how we've got degrees Fahrenheit, degrees Celsius. If anything, you have the letter K here, 373.15 Kelvin. And then 0 degrees Celsius is 273.15 Kelvin. Okay, so the conversion from Kelvin to Celsius is super easy. If you know the math, or if you know the temperature in degrees Celsius, well then simply add 273.15 and boom, now you have the temperature in Kelvin. Okay, so all that we need to do is say K is equal to degrees Celsius plus 273.15. Okay, thermometers just sitting around in the lab typically read about 22 degrees Celsius. Convert this room temperature reading to Kelvin. Well, 22 there, K is equal to 295.15 Kelvin. Easy. Now, convert 325 Kelvin to degrees Celsius. Okay, well, 325 Kelvin to degrees Celsius, what we need to do is we simply need to say K is equal to degrees Celsius plus 273.15. Well, plug in 325. K is equal to degrees Celsius plus 273.15. Subtract 273.15 from each side, minus 273.15. And now, let's see, that would be around 52 degrees Celsius. So I'm going to go with answer option D. There we go. All right, well, that concludes the Chapter 1 material. And if there's anything else that comes up, I'll be sure to add a video and add anything else that you need. But that wraps up chapter number 1. So I hope this is helpful, and please contact me during office hour, or contact me. We can set up a meeting or come by my office hours, or get in or be sure to go to your SI so that you can ask questions. All right, well, have a good one.